Question 729. Let A be the region in the first quadrant bounded by the graph of y is equal to x squared plus 1 over 2 and the vertical line x is equal to. If the region A is rotated about the x-axis, which of the following represents the volume of the solid generated? Okay, first thing we have to do is that we have to draw this graph. Y is equal to x squared plus 1 over 2, that's quadratic, right? X squared over 2 plus 1 over 2. So from 1 over 2 right here, it's a parabola, right? So it looks like that. And x is equal to, the vertical line x is equal to, let's say we have it right here. That's x is equal to. So bounded region in the first quadrant is this. Right over here, right? And we're gonna rotate this region about the x-axis. So it's gonna be like that, right? And we have point here, so about same distance. It's gonna be like that. Okay, so the cross section is a circle, right? It's a disc. So here's the center. This is our cross section, which is a circle. And the radius is this, right? Radius of circle, let's say this is r. That's function y, right? That's a function y, right? That is equal to, in terms of x squared plus 1 over 2, right? The volume is equal to then integral from here 0 to 2, 0 to 2, and we have to have area of the circle, right? Area of the circle, cross section, in this case it's a circle, times height. The height is the instantaneous change in x, right? So that's gonna be dx. So we have to write the area of a circle in terms of x here. So the volume is equal to integral from 0 to 2. The area of a circle is pi r squared, right? Pi r squared dx, and this r must be in terms of x. So that's going to be equal to, let's write pi right over here, 0 to 2 r squared. Here r is x squared plus 1 over 2, right? So that's going to be x squared plus 1 over 2 squared dx, right? So that is equal to, let's write right over here, pi from 0 to 2. Here we have 2 squares, so 1 over 4 times x squared plus 1 squared dx. Or we can write pi times 1 over 4. That's just the pi over 4, right? Pi over 4. So the answer is right here. The answer is D. All right. Question 733. Let A be the region in the first quadrant bounded by the graph of y is equal to natural log x over 2 and the horizontal line y is equal to 1. If the region A is rotated about the y-axis, which of the following represents the volume of the solid generated? Okay, we have y is equal to natural log x over 2, right? When x is equal to natural log 1, that's 0. So when x is equal to, y is equal to 0, right? So let's say this value is 2. And the graph of log looks like that, right? Okay, so that's y is equal to natural log x over 2. And we have a horizontal line y is equal to 1, right? Let's say here's 1. So we have this horizontal line. So bounded region is here, right? And this region is rotated about the y-axis. Okay, so it is rotated about y-axis. Then we're gonna have here this type of graph, right? Here's -2, like that, right? So that's the figure that we're looking for. We're gonna find the volume of this figure, right? Now let's draw one cross section. Let's see, here's the center. So here we'll have cross section which is equal to circle, right? And the radius is from here to here, right? That's our radius, and radius is x of this curve, right? Let's say we have function right here, okay? At this point, if this is our radius, that's y of this curve, right? So that's y of this curve. Or if this is our radius, then this r is x of this curve, right? Does that make sense? Since we have a radius from here to here, that's x of this curve, right? Does that make sense? Okay, what's our height? Our height is change in y, right? Instantaneous change in y, dy. So our volume is equal to integral from 0 to here 1, right? Since it's a dy from 0 to 1, and we have to write the area of the circle here, right? Which is pi r squared, and r has to be in terms of y. So far so good. So pi times, that's constant, right? So pi times integral from 0 to 1 r squared. R is x of this curve, right? So we're going to have to find x in terms of y. So y is equal to net log x over 2, right? So e to the y is equal to x over 2. Then our x is 2 times e to the y. So that's our radius, pi r squared. R squared is 2 e to the y squared dy, right? So that's going to be pi times 0 to 1. 4 e to the y squared, that's going to be y times 2, 2y, right? So that is equal to 4 pi 0 to 1 e to the 2y dy. That's our volume, right? So the answer must be B. Question 734. Let A be the region in the first quadrant bounded by the graphs of y is equal to root x and y is equal to x over 2. If the region A is rotated about the x-axis, which of the following represents the volume of the solid generated? So we have y is equal to square root of x and y is equal to x over 2, right? Square root of x, it looks like that. Y is equal to x over 2, that's linear, right? And they're going to intersect at some point here, right? So this is our bounded region, and we got to find this intersection of x, right? Let root x is equal to x over 2, then 2 square root of x is equal to x. If we square both sides, then that's going to be 4x is equal to x squared, right? Since this is quadratic, we have to eliminate 4x on the left. So x squared minus 4x is equal to 0. So if we factor this, that's going to be x times x minus 4 is equal to 0. So x is 0 or 4. Here's a 0, here's a 4, right? And we are rotating this region about x-axis, right? So we're going to have this line and this curve like this, right? If we draw our one of the cross section, the center is here, this is washer, right? If we draw this cross section right here, we're gonna have this concentric circle, right? So let's say this is a small r, and let's say this is capital R. Okay, our capital R is from here to here, right? That's y of this curve. Y is equal to square root of x, right? So this capital R right here, R is y, but in terms of x, that's the square root of x. What's our small r? Small r is from here to here, right? So that's our small r, and that's y of this line, right? This line right here. So that's going to be y, but in terms of x, that's x over 2, right? So the area of this cross-section, is pi r square minus pi r square, right? So our volume is equal to, from 0 to 4. Remember, the height is change in x, right? So volume must be integral with the dx from 0 to 4, and we have to write the area of the cross-section right here, which is pi, if we factor pi r square minus r square. So far so good. So that is equal to pi times definite integral from 0 to 4 r square. Our capital R is the square root of x, right? So that's going to be square root of x square minus small r square. Small r is x over 2, right? So x over 2 square. All of this thing dx, right? So that is equal to pi times 0 to 4 square root of x squared, that's x, minus x squared over 4 dx. That's our volume, right? So the answer must be A. Question 735. If the region A is rotated about the vertical line x is equal to 4, which of the following represents the volume of the solid generated? Here we have y is equal to square root of x, y is equal to x over 2 again. So we have this graph and this line, right? And this is bounded region, intersection was 4, and x is equal to 4, right? And we are rotating this region about the vertical line x is equal to 4. So this line right here, that's x is equal to 4. And then we're going to rotate the region about this line. So we'll have line right here and curve. And let's draw the circle right here. That's the figure, right? So let's draw the cross section. The center is right here with a circle like that, right? So the cross section is right here with a small r, capital R, right? Small r is from here to here, right? The distance from here to here is always equal to 4, right? This is a 4. So small r is 4 minus x of this line, right? Here's the line. So 4 minus x of this line is our small r. Does that make sense? So this is our small r. That's 4 minus x of the line, and x is equal to 2y, right? So we can write that is equal to 4 minus 2y, right? What's big R? Capital R. Capital R is from here to here, right? From center to up to this point right here. So that's going to be equal to 4 minus x of this curve, right? X of this curve. So that's going to be here, capital R. Let me write right up here. Capital R is equal to 4 minus x of this curve, and that is equal to x is equal to, if we square each side, that's going to be y squared, right? So 4 minus y squared. So far so good. Now the volume is equal to integral. What's our height? Our height is change in y, right? dy. So integral with the dy, pi r squared minus r squared, from 0 to up to this point right here. When x is 4, here, when x is 4, y is equal to 2, right? When x is equal to, y is equal to. So this value is 2. So from 0 to 2 equal to pi times integral from 0 to 2 r squared. Capital R is 4 minus y squared squared minus small r squared, 4 minus 2y squared dy, right? So the answer is right here, A, right? Pi 0 to 2, 4 minus y squared squared minus 4 minus 2y squared dy, right? Question 738. Let A be the region bounded by the graphs of y is equal to 2x squared minus 2, y is equal to 4, and x equal to 0. And the region is rotated about the line y is equal to 4. Write, but do not evaluate, an expression involving one or more integrals that gives the volume of the solid. Okay, we have y is equal to 2x squared minus 2. That's a quadratic function with the y-intercept -2. So let's say here is -2. So it looks like parabola, right? And let's say this line is y is equal to 4. And x is 0 is y-axis, right? So bounded region is here. And we're going to rotate this region about the line y is equal to 4. So about this line, right? So the solid would look like it looks like that, right? So let's draw the cross section. The center is right here, and our cross section is circle, disc, right? With the radius from here to here, right? That's our radius, r. Okay, so what's our radius? Radius is this curve minus this curve, right? The distance from here to here is y is equal to 4 minus this y right here, which is equal to 2x squared minus 2, right? So that is equal to 4 minus 2x squared minus 2. Upper curve minus lower curve. So if we simplify this, that's going to be 4 plus 2, so 6 minus 2x squared, right? So the volume of this curve is equal to integral. What's our height? Height is change in x, dx, right? So integral with dx from 0, here's a 0, right? Here's a 0. And what is this value right here? We actually have to find this intersection, right? Intersection of these two curves. Y is equal to 2x squared minus 2 and y is equal to 4, right? So 2x squared minus 2 is equal to 4. Then 2x squared is equal to 6. X squared is equal to 3. Then x is plus or minus 3, but this is positive, right? So square root of 3, right? So that is, the interval is from 0 to square root of 3 pi r squared. And this r is right here, right? So pi times 0 to root 3 r squared 6 minus 2x squared, right? This is our volume, right?